Hello everyone, welcome back to another episode of RGH3 101. And in today's video, we're going to cover what happened from the moment you turn on your RGH console, from the moment you power it on, all the way to the dashboard. So we're going to be covering what is RGH, how it works, and why it exists, and everything that happened from the moment you power on your console, all the way to the dashboard. Now, do note that this is not an installation guide. It's more of a theory and foundation of what happens behind the scene on the RGH3 console. So let's get to that and I'll explain everything. When you press the power button on an Xbox 360, a lot happens before you see the dashboard. Imagine the Xbox is like a big robot. When you turn it on, it has a wake up step by step before it can play game. Power on begins executing at 1BL, an immutable RAM inside the CPU that establishes the hardware root of trust. The Xbox 360 uses something called a chain of trust. Each stage verifies the stage before allowing it to run. If any step fails, the console resets and try again. That chain looks like this: 1BL, CB, CD, and CF, hypervisor, kernel, and finally the dashboard. Each step checks the next one to make sure nothing bad is happening. If something looks wrong, the Xbox restarts and try again. The boot chain enforces sequential cryptographic verification. Failure at any stage cause a reset, enabling repeat boot attempt. The first thing that runs is called 1BL. This code lives inside the CPU itself. It cannot be updated, modified, or replaced. Its job is to verify the next bootloader, CB. The first step lives inside the robot's brain and can never be changed. That's how the Xbox knows it can trust itself. 1BL initializes minimal hardware and authentication, CB, using CPU-bound secrets. CB is where security really tightens. It initializes memory protection, check anti-downgrade fuses, and run under extreme strict timing conditions. That timing sensitivity is what RGH eventually takes advantage of. The next step is like a guard checking IDs. It works very fast, and that speed is important. CB configures memory protection, check E-fuses, and operates under tight timing constraints that makes it susceptible to fault injection. These stages build the running system. They load the base kernel and hypervisor, then apply patches before the system starts. This allows Microsoft to harden security over time without changing hardware. After that, the Xbox builds its system and adds upgrade before it even starts. CD and CF loads the CE image containing the base kernel and hypervisor. Then apply CG patches before execution. The hypervisor runs below the kernel and controls it. It enforces signal code, manages memory access, and isolates game. This is why patching the dashboard alone never works. The boss of the Xbox is called the hypervisor. Even the operating system has to listen to it. The hypervisor operates at a high privilege level than the kernel, enforcing signed execution and memory isolation. RGH is a hardware timing attack. A very small, precise glitch during boot can cause a security check to mis-execute once. If it fails, the console restarts and try again. If it succeeds, you gain control. RGH is like making a guard blink for a tiny moment. When that happens, the Xbox let you do more things. RGH exploits timing inability during CB execution, causing a security check to misevaluate and allow an alternate boot path. As Microsoft hardened the system, RGH evolved. RGH1 became RGH2, then RGH1.2, and finally RGH3. Same concept, deeper understanding. Over time, the Xbox makers tried to stop this, and hackers find smarter ways to do it. Later dashboards and hardware revision alter CB behavior, requiring refinements such as DLL or SMC assist glitching. RGH3 removes the external glitching chip. It uses the console's own system management controller to perform the timing behavior. This results in cleaner installs and fewer parts. RGH3 is the newest way. It doesn't need extra parts and uses the Xbox own controller chip. RGH3 replaces external glitching hardware by leveraging the SMC to induce the required timing behavior. RGH is not about piracy or cheating. It's about understanding a system so well that you can bend it without breaking. Everything else in RGH3 101 builds on this foundation. RGH is about learning how things work, not breaking them. RGH represents a fault injection victory over a well-designed chain of trust system. See, that was a lot of information to take in. I did my best to make it as simple as possible. So, if there's any other type of modification you'd like me to cover, like JTAG or anything like that, do let me know in the comments below and I'll do some research and I'll make it as simple as possible. Like and subscribe and leave your comments down below. See you in the next one.